In this video, we're going to take a look at MRAM4, the midpoint rectangle approximation method. So as you may notice, I have the rectangles drawn into the diagram. Part of the rectangle would be above the curve, part of the rectangle would be below the curve, resulting in part of it being an overestimation, part of it being an underestimation. It turns out to be a pretty good average of the two. So if you noticed when we did the LRAMs, that was an underestimation, and the RRAMs were an over approximation. So now we're going to get something that's in the middle, but not quite exact, due to the nature of the fact that the curve, actually has curvature to it. So this is not, there's not like an equal amount of area above this rectangle and below it. Not exactly, pretty close. So in order to do this problem, first we put the rectangles in the diagram as such. Then we find the width of each rectangle. Highest x value minus lowest x value divided by number of rectangles. So 5 minus 1 divided by 4 rectangles in this case. So the width of each rectangle is 1. So it's time now to set up our chart. So first we start with the k values 1, 2, and 3, which represent the rectangle numbers. So this, remember, is going to be a chart that helps us convert once we use the sigma notation. And what we're trying to find is the appropriate x value to plug in to each rectangle so that you can find the height of that particular rectangle based on the fact that it does touch the curve y equals x squared plus 3. So for the first rectangle, it looks like we would use halfway between the left and the right side of it, so 1.5. The second rectangle would be at 2.5. The third rectangle, the x value would be at 3.5. Leading us to the equation x equals k plus 1/2. So when k is 1, it's 1.5 to 2.5, so it's always a half more. Write these as a fraction is always the easiest way. So common denominator with k and 1/2 is 2, so 2k over 2 plus 1/2, which gives us 2k plus 1 over 2 when we combine. So that was the value I would use to plug in for the x. The approach with the sigmas is not going to change since we're using 4 rectangles. It's k equals 1 to 4, area of the kth rectangle. But each rectangle has the formula for area of base times height. The base in this case, which is also known as the width or the delta x, is 1. And the height can be found using the equation x squared plus 3. But as we know, we're going to rewrite that expression without the x because for the x we are going to put in 2k plus 1 divided by 2. First job would be to square this quantity. Square in the numerator, we would get 4k squared plus 4k plus 1, and square in the denominator, we'd get 4. Don't forget we still have the plus 3, and since it's the entire quantity times 1, at this point I'm going to leave that out. Combining like terms, actually over here, plus 3 can be written as 12 over 4, meaning that this would be plus 13 over 4 in the end. So breaking this fraction apart, 4k squared over 4 becomes k squared, 4k divided by 4 becomes k, and then we have the 13 over 4. Breaking each into its own sigma, we are now ready to apply the formulas for k squared, n plus 1, 2n plus 1 divided by 6. For k, n plus 1 over 2, and for a constant, sigma constant, n times constant. So simplifying here, the first term is 30 plus 10 plus 13 for a grand total of 53. And the exact area would actually be 53 1/3, so that's a pretty good estimate in this case.